Welcome. This is a video on the Emergency Planning and Community Right to Know Act, known as EPCRA. It is also known as SARA Title III. The two terms are the same. EPCRA and SARA Title III are the same. There are four parts to EPCRA. The first part, the federal law requires the governor of each state to plan for emergency, to plan for chemical emergencies. The second part requires companies to let the public know what kind of chemicals they have within the facility boundaries. This is known as the right to know portion of the federal law. And the third part is release notification. What the federal law says is that if a company were to release a certain amount of chemicals outside of its facility boundaries, then it has an obligation to report to the government or to report to certain government agencies. That's known as the release notification. And later on, we're going to talk about the list of lists. There's a list that has been compiled by the EPA that lists all the chemicals that have a reportable quantity associated with it. And so we're going to take a look at how to make use of the list of lists to prepare for a chemical release or chemical emergency. And the fourth component of EPCRA is toxic release inventory, also known as Form R. This is a report that is due July 1st of every year. If a company releases more than a certain amount of chemicals to the environment, we're going to take a look at what that means and how you should go about complying with that requirement. There's also, as part of the Right to Know Act, there's a Tier 2 report. This is required of all facilities outside of California, that they need to file a report by March 1 of every year and let the community knows what kind of chemicals they have within the boundaries. Now in California, you do not do a Tier 2 report. Instead, you file a business plan. The business plan, also known as the hazardous material inventory list, and this is a more comprehensive list than Tier 2 report that is required of all companies in California, and it supersedes the federal requirement of doing a Tier 2 report. We're going to show you a very short video on an event that led to Congress passing EPCRA.
At midnight, December 2nd, 1984, the worst industrial accident in history occurred at a U.S.-owned pesticide manufacturing plant in Bhopal, India.
It was a reactive chemical accident. Methyl isocyanate is highly reactive with water.
Dennis Hendershot is an industry consultant in chemical process safety and has toured the now abandoned Bhopal accident site.
Water got into the storage tank somehow. Water reacted with the methyl isocyanate, causing the release, which killed thousands of people.
Thousands more died in the aftermath of Bhopal, and tens of thousands continue to suffer today. But Bhopal also brought about change.
Bhopal totally changed the understanding of potential process safety hazards in the chemical industry.
Bhopal spurred Congress to require new OSHA and EPA regulations covering chemical process safety. And Congress established the CSB to independently investigate chemical accidents.
There have been many positive changes in chemical industry process safety since 1984, when the Bhopal nightmare occurred.
Law. EPCRA governs release of hazardous substances and also extremely hazardous substances that could affect the community. An example of extremely hazardous substances, EHS, would be chlorine and ammonia. These are chemicals that could cause acute reaction to people when they're exposed to these chemicals. And the list of EHS, the extremely hazardous substances, can be found in Title 40 of the Code of Federal Regulations, Section 355. The federal Superfund law governs the release of hazardous substances from onshore and offshore facilities. So if you have a factory and you release certain amount of chemicals off-site, then under the Superfund law, you have a legal obligation to report to the Coast Guard. And we're going to talk about some of the procedures that you need to follow when you have such a release. If you have an offshore facility, just such as a drilling platform, for example, offshore platform, you also have to comply with Superfund's release reporting requirement. There are also other laws, federal laws that define different chemicals under different names that have reporting requirements. For example, hazardous substances are also identified under the Clean Air Act, and many of these chemicals are the same as the chemicals you find in extremely hazardous substances under EPCRA. So every federal law has its own list of chemicals, and that's why later on we're going to take a look at the list of lists, which compile all of these different lists under different laws into one gigantic list. For example, under the Clean Water Act, you have these priority pollutants that are basically hazardous substances that have been identified in the Clean Water Act. An example will be chlorine and ammonia. Both of these are identified as priority pollutants under the Clean Water Act, and they are also extremely hazardous substances under EPCRA. And then you have hazardous waste that have been identified under the Resource Conservation Recovery Act, RCRA. So these are hazardous waste that have been identified by EPA through a set of procedures, and these have been listed in the federal regulations as hazardous waste, also known as listed waste. If you have chemicals that are radioactive or you have PCBs, then these chemicals are also regulated as hazardous substances under various federal law. One of them will be the Toxic Substances Control Act, which will regulate PCBs. There are three general concepts under EPCRA. The first concept is reportable quantity. So we're going to take a look at what do we mean by reportable quantity, RQ. Every chemical has been assigned a specific RQ. What that means is if you release more than the RQ, then you may trigger a reporting obligation on your part. And every chemical on the list also has a threshold planning quantity, the TPQ. This is the amount that would trigger the preparation of a Tier 2 report under the Community Right to Know section of the law. Now, we keep talking about released to the environment. The concept of a release to the environment is pretty broad. Let me give you some examples. If you could have a release to the atmosphere, that will be considered to be a release to the environment. So, for example, if you are holding some highly volatile chemical compounds inside your factory and you spill these highly volatile chemicals inside your facility boundaries, some of these chemicals would be released to the air through the air vent because they're highly volatile. So that will be classified as a release to the environment, the environment being air. Another release would be if you spill chemicals outside your facility boundaries on land. That will be a release to the environment as well. And another one is if you release chemicals into the ground into the underground aquifer, into underground water table. You have a release to the environment. Anything released below ground is considered to be a release to the environment. So EPCRA, as a federal law, requires every governor of each state to set up a set of procedures in the event of a chemical accident. So every state must have a State Emergency Response Commission, SERC. And now some states keep the name as SERC. Other states may have a different name, but the function is the same. The job of a SERC, a State Emergency Response Commission, is to coordinate emergency response effort through the state in the event of a chemical emergency. Now, under the State Emergency Response Commission, there'll be a whole host of Local Emergency Planning Committee, the LEPCs. These are primarily your front-line responders, such as your firefighters, for example. So within each state, there'll be a whole bunch of LEPCs set up under the federal law. And the function of these LEPCs is to let the community know what kind of chemicals are within those communities. And very often, these LEPCs are chaired or managed by the environmental managers of the largest company within that community. So if you happen to be the environmental manager of a big chemical company within a city, within a small city, chances are you're going to be invited by the governor to head up the LEPC because your company has the most likelihood of impacting your community. In California, the State Emergency Response Commission is known as the California Emergency Management Agency. So as I said earlier, every state has its own, may decide to call their SCRC a different name. So the key to management spills is preparation. You know you're going to have a chemical spill sooner or later. So the trick is you need to plan for your next accident. So what you need to do is to do some homework and get ready so that at 2 o'clock in the morning, when your cell phone rings, somebody calls you and tells you that there's a chemical spill at your facility. Then you have the resources, you have the word, you have the resources to respond to that call, to make to take the proper action to respond to that spill. And the best way to prepare for your next chemical spill is to first of all look at your chemical inventory. By the way, under OSHA's chemical hazard communication regulations, standards, there's a standard that requires every company to have a complete list of chemicals that they have in their inventory. So now that you have this list of chemicals, what you want to do is to compare that list of chemicals against the list of lists. So if you have a chemical that appears on the list of lists is going to tell you what the reportable quantities are for that specific chemical under various federal law. It will give you an example. I'll show you an example of the list of lists. So if you look at the first one, the first chemical, formaldehyde, it tells you that the chemical abstract service number CAS is 50-00-0. It's formaldehyde, and it tells you that formaldehyde is an extremely hazardous substance. EHS stands for extremely hazardous substance, with a TPQ, with a threshold planning quantity of 500 pounds. All the units in this table are in pounds. And it also tells you that formaldehyde is also an extremely hazardous substance under Section 304 of the of the EPCRA law, and it has a reportable quantity of 100 pounds. So we know that formaldehyde has a threshold planning quantity of 500 pounds and a reportable quantity of 100 pounds. Formaldehyde is also a circular hazardous substance. Circular is the same as Superfund law. So formaldehyde is a Superfund chemical hazardous substance that carries the same reportable quantity of 100 pounds. It is also a Clean Air Act amendment, Section 112R chemical. So what it tells us is that formaldehyde has been listed under the Clean Air Act as a hazardous air pollutant, and it carries a threshold quantity of 15,000 pounds. So what that means in this case is that if you have more than 15,000 pounds of formaldehyde on site, under the Clean Air Act, you're going to have to prepare a risk management plan, an RMP. So that's what the TQ stands for, threshold quantity for RMP, risk management plan, under the Clean Air Act. The table also tells you that formaldehyde is a Section 313 chemical under EPCRA. Section 313 refers to Form R, the Toxic Release Inventory section. So what that means is if you use or manufacture or process more than so many pounds of formaldehyde during a particular calendar year, in the following calendar year, you're going to have to file a Form R report under Section 313 of EPCRA. Now, the last column tells you that formaldehyde, if you were to dispose of a jar of formaldehyde as a waste, it carries a waste code under RCRA of U122. So just by looking at this table, it tells you a lot about formaldehyde. It tells you that it has a TPQ of 500 pounds. It has a reportable quantity under various laws of 100 pounds. And all of these RQs and TPQs refer to the pure chemical substance. So for example, if I have a solution that is made up of 50% formaldehyde, and I know that the RQ, the reportable quantity of formaldehyde, is 100 pounds. Since this solution contains 50% formaldehyde, it means that I will have to spill 200 pounds of this chemical before the reportable quantity will kick in. Right? So the reason why you want to do this homework is that you're going to identify the RQ for all your chemicals, and based on the composition of those pure chemicals in the chemical compounds that you have at your facility, you're going to be able to calculate what amount of your compounds that you need to spill before it will trigger an RQ or reportable event, because you have to do your calculation based on the composition and the reportable quantity. So that's where the homework comes in. At 2 o'clock in the morning, when your cell phone alerts you that you have a chemical spill, now is not the time at 2 o'clock in the morning to calculate whether or not you have a reportable quantity action on your hand. You want to have a table already prepared earlier that tells you that, okay, I released so many gallons or so many pounds of this chemical, therefore, based on the composition, it will have triggered a reportable event. So I need to pick up the phone and contact the agency. So that's the whole purpose of doing your homework beforehand. So if you spill more than the RQ, the reportable quantity, you have to notify the National Response Center. The NRC is run by the Coast Guard 24/7. So what you have to do, if you exceed the RQ, you have to call this number 1-800-424-8802 and talk to the Coast Guard duty officer. You have to let them know what kind of chemical you spill, the estimated amount of chemicals that have been spilled that has exceeded the RQ, and you have to tell them whether or not somebody has been injured and steps you have taken to contain the chemical spill and so forth. So at the end of that that phone call, the duty officer is going to assign you a number, a reference number. That is proof for you to show to the agency that you have complied with the reporting obligation. So it's very important for you to obtain that reference number after the duty officer has asked you a whole bunch of questions and you've answered them. So the number again is 1-800-424-8802. So you probably want to tattoo that number on somebody's forehead. So next time you have a chemical spill, you know this is a number to call. So you report your spills to the NRC, and you can do it by phone, do it in writing, or you can do it in person. Most people do it by phone. You also have to report to the NRC if you spill those Superfund hazardous substance. And you report to the NRC if you have an oil spill, and if you spill those EPCRA extremely hazardous substances such as chlorine or anhydrous ammonia, you also have to report to NRC, and maybe EPA or the state agencies. Now, the reason we focus on that is that bad things will happen to you if you fail to report your reportable spills or releases in a timely fashion. Here's what happened to a company in Chicago. This is a press release from EPA that says that this company released 5,490 pounds of toluene to the atmosphere. Now, toluene is a pretty hazardous chemical. It has a reportable quantity associated with it. So 5,400 pounds obviously has exceeded the reportable quantity. And what happened was that the company waited 10 hours or more before they called the NRC. The agency hit them with $144,000 fine as a penalty for failure to notify the local emergency planning committee and waited too long to report to the Coast Guard. Now, another thing you need to be aware of is that individual states may have additional spill reporting requirements. Not all of them do, but some states will require you to report any amount of spill outside your facility boundaries. Even 1 gallon of gasoline, you're supposed to pick up the phone and contact the state agency. And other states will just defer to the federal reporting requirements. So we've put together a table of all the 50 states and the spill reporting requirements, and you can download this table at the end of our video after you've watched our video. So you always want to understand what your state spill reporting requirements are, because that could be an additional burden on you, additional reporting requirement on you over and above what the federal government requires you to do. Give you an example. A release reporting in California is very different. What the California law says is that if you have a release, you have to report any amount of release regardless of the amount, unless you can demonstrate that there's no significant present or potential hazard to human property or the environment. So the onus is on you as an operator to determine whether or not there has been significant hazard to property, human, or environment. And if you do feel that there has been significant hazard, then you have to report that release to the state agency regardless of the amount being released. Remember, the federal government only requires you to report a release if the release exceeds a reportable quantity. Not so in California. I'll give you a classic example. A company had a minor release of anhydrous ammonia from its refrigeration system. When an operator was working on the system, he turned the valve the wrong way. He got a blast of anhydrous ammonia in his face. The amount released maybe 5 pounds. So the operator was sent to the hospital for observation. Now, the federal reportable quantity for anhydrous ammonia is 100 pounds. So in this case, under federal law, there's no reporting requirements as far as the federal government is concerned. However, if this incident happened in California, because the operator got sent away to a hospital for observation, the management of the facility cannot reasonably argue that there was no significant potential impact to human health. I mean, his employee got sent off to a hospital for observation. So based on that scenario, what the facility manager has to do is to pick up the phone and contact the state agency and report that event as a California reportable event, even though the federal government does not require you to report it because it's only 5 pounds of anhydrous ammonia as opposed which is way below the RQ threshold. So there's a form that you have to fill out within 30 days in California after you made the verbal notifications to the state agency. The general rule of thumb is that your first concern is the safety of your employee. After you've contained the release, then you pick up the phone and contact the state agency. And then within 30 days, you file a written report to the state agency. So in California, now if you release more than 100 pounds of anhydrous ammonia and the operator also gets sent out to the hospital for observation, then you can have 2 reporting requirements. One to the state agency because it poses potential human health hazard, and 2 because you exceeded the RQ for the federal reporting requirement. The Tier 2 report requirements are pretty straightforward. What it says is that if you have a list of extremely hazardous substances, if you have any extremely hazardous substances that if you have more than 500 what it says is that if you have more than 500 pounds of an extremely hazardous substance, or the TPQ, whichever is less of that substance, then you have to file a Tier 2 report. In other words, you have to file a report with the state agency to let the community know that you have these specific extremely hazardous substances on site. However, in California, you don't need to do that because in California, they require you to file a hazardous material inventory form, known as business form, known as business plan. And this form that you're required to fill out in California is more stringent than the federal requirement. So the federal government has accepted the state of California form as adequate fulfillment of the federal requirements. And as a matter of fact, there's a letter from EPA Region 9 in San Francisco stating to that effect that if you comply with the state requirement, then as far as the federal government is concerned, the government will consider you have also fulfilled the requirements for the federal for the Tier 2 report. Now we talk about the Toxic Release Inventory, Form R, which is due July 1 of each year. It's also known as Toxic Release Inventory. It has two sets of thresholds. The first set pertains to manufacture and process. So if you manufacture or process more than 25,000 pounds of a specific chemical, then you have to prepare a Form R report for that chemical. And then the second category is otherwise used. So we're going to take a quick look at the definition of manufacture or process and otherwise used. Manufacture means you make a product, you produce, you prepare, you import, or you compound a toxic chemicals that falls in under the definition of manufacture. Process means if you add chemicals to a process, if you add chemicals to a substance in order to enhance performance, then you're processing the chemical. Or if you repackage a chemical from a larger volume to a smaller volume for the purpose of selling it to the general public, then you're engaged in the processing of that chemical. So the threshold is 25,000 pounds or more. So if you process more than 25,000 pounds of a specific chemical, then you have to prepare a 4-mile report for that chemical. Examples of otherwise used would be chemicals that you use as processing aid. So, for example, if I use chlorine as a disinfectant at my wastewater treatment plant, I am otherwise using chlorine as a chemical. So if I use more than 10,000 pounds, remember the threshold for otherwise used is 10,000 pounds. So if I use more than 10,000 pounds of chlorine at my wastewater treatment plant, I have to file a Tier 2 a 4-mile report for chlorine because I've exceeded the threshold amount, which is 10,000 pounds for otherwise used. The same with anhydrous ammonia. If I used up 10,000 pounds of anhydrous ammonia as a refrigerant, I have to file a 4-mile report for anhydrous ammonia. When I say used up, meaning consumed. Now, in the context of a refrigeration system using anhydrous ammonia, the term consumed means that you have released that amount to the environment. So what I have to do is I have to go back and look at my purchasing record. If last year I had to purchase more than 10,000 pounds of anhydrous ammonia to replenish my refrigeration system, it means that I have consumed more than 10,000 pounds within my system. So I have to file a 4-mile report for anhydrous ammonia. Okay, so it's not based on how much you have on site, it's how much you have consumed. The same way that I consumed my chlorine at my wastewater treatment plant, as opposed to in the same way as I consumed 10,000 pounds of anhydrous ammonia within my refrigeration system. There's certain exemptions for 4-mile within the context of a laboratory. So there's certain laboratory exemption. So the two basic steps you have to take to prepare your form are: first step is figure out your threshold. Have I exceeded the 25,000 pounds for manufacture or process, or have I exceeded the 10,000 pounds for otherwise used? And if the answer is yes, then I need to go back and estimate the total amount of that chemical being released to the environment once my usage has exceeded the applicable threshold. EPA now has for you to file a 4-mile report, you have to go to EPA's website, sign up for one of the programs, and you have to do everything online. In other words, you're going to be filing an electronic copy of your 4-mile report with EPA and the state agency. So the EPA, the computer program, is going to walk you through, ask you a whole bunch of questions as to how much you have used up, how much you have released to the atmosphere, how much you've released to the environment, how much have you recycled, and so on. So it's pretty straightforward that you can go through, just let's go through all the questions and answer them, and then you'll have your report prepared that way. There are also a whole bunch of guidance documents on EPA's website specific to individual industries on how they can prepare the 4-mile report. Now we want to talk a little bit about chemical accident investigations. In the old days, EPA and OSHA had the Memorandum of Understanding on chemical accident investigations. If you have a chemical accident that causes more than so many dollars of property damage, or if there's been fatalities, then EP and OSHA will go in and do a joint investigation of that particular chemical accident. They don't do that anymore because now the U.S. Chemical Safety Board has taken over. So the U.S. Chemical Safety Board will investigate chemical accidents. So anytime you hear in the news that there's been a major release of certain chemicals or to the environment, you can pretty sure that the U.S. Chemical Safety Board will get involved in investigating the accident, and they will generate a report and they'll make recommendations to OSHA or to EPA or to the federal government on how best to avoid future accidents of a similar nature. So the reason we mention this because most accidents occur because of human errors, and these reports highlight for us the specific nature of those human errors. And so if we read these reports, we're going to have the foresight to learn from other people's mistakes so that we don't make the same mistakes ourselves. So to give you an example, here was a chemical accident that happened in May of 1997 at a warehouse, and there was a big fire, and several firefighters died as a result when they went in there to fight that, to put out that fire, and there were a lot of property damage. So EP and OSHA went in and did a joint accident investigation back in those days. And what EP and OSHA found was that the fire was caused by a pesticide known as AZM, and they discovered that the pesticide was stored near a hot water discharge pipe at high temperature, which caused the pesticide to decompose and generate heat and cause the fire. So the question often is asked is that, well, could this accident have been prevented? Well, all we have to do is to look at the material safety data sheets for AZM. All we have to do is to look at the material safety data sheets for AZM. Here you see that in section 7, handling and storage, the MSDS tells people to store the chemical in a well-ventilated area, dry place, away from heat, heat being defined as anything over 100 degrees Fahrenheit. And then in section 10 of the same MSDS, it says that this chemical could decompose if heated, avoid temperature above 100 degrees Fahrenheit. So what happened was that whoever stored this chemical right near the hot water discharge pipe failed to read the MSDS prior to storage. So that was a very common incident of human error. People not paying attention to the MSDS and storing the chemical in the wrong place, thereby causing the fire. So these are things that we can learn, as I said, from other people's mistakes. Now we'll want to take a look at how to prevent chemical spills by considering some practical aspect of it. The key to emergency response to a chemical spill, the first thing is community planning. We're going to show you a short video clip from the U.S. Chemical Safety Board on what happens if there's a lack of community planning.
The key to emergency preparedness is to be aware of what chemical hazards are in your community and where they're located, so that you can plan for a proper response.
Danvers, Massachusetts, November 22, 2006. A massive explosion at a chemical facility devastated a nearby neighborhood in the middle of the night. The blast wave blew through windows into the bedrooms of sleeping residents, protected only by bed covers, as glass shattered and ceilings collapsed. In what some called a miracle, there were no fatalities, and only 10 residents were injured, suffering cuts and bruises. CAI, an ink manufacturer, was located on an industrial site where flammable solvents had been stored and used for decades. Yet residents of the Danversport neighborhood, which grew up nearby over the years, were unaware of the potential danger. An operator likely forgot to turn off the steam heating for an ink mixing tank before leaving for the night. The steam continued to heat flammable solvents in the tank for more than 8 hours, causing them to boil. Flammable vapor filled the unventilated building and exploded.
The fact that a chemical company could cause that much destruction, a small chemical company, is something that surprised, I think, all of us.
Local emergency planning committees, or LEPCs, are required under the 1986 Federal Emergency Planning and Community Right to Know Act. The committees provide residents, officials, and emergency responders with a system to prepare for chemical accidents. The Danvers LEPC had not met for years. It was revitalized after the accident by town officials and concerned citizens.
And the newly resurrected Danvers LEPC has expanded its largely emergency-based charter to include looking into what we can do to prevent a recurrence of this type of tragedy.
The second key to emergency response is good communication. Here's another short video from the Chemical Safety Board on what happens when there's lack of communication after a chemical spill, after a chemical incident.
We just have an emergency alarm in progress right now.
Do you know what area of the plant or anything?
Well, I can't give out any information. Like I say, we will contact you with the proper information.
In August 2008, a chemical explosion occurred at the Bayer pesticide plant in Institute, West Virginia. 2 workers were fatally injured. Authorities told tens of thousands of residents to shelter in place. Responders struggled to learn what chemicals were involved in the accident and what precautions they should take.
We had reports it was in a larvae unit. Are you able to confirm or deny that?
No, that's all. I'm only allowed to tell you that we have an emergency in the plant.
At the end of the night, I knew no more than I knew driving up Interstate 64, and that was approximately 6 hours later.
Per hazmat team, this smoke is toxic.
CSB investigations show the need for effective communications between companies, responders, and communities, not only during a chemical emergency, but before a disaster strikes.
The only way you can approach community preparedness is having a good understanding of the risks that are present in the community. And that means you have to develop communication with everyone who is handling the hazardous chemicals in that community.
And the third key to emergency response is training. So we have a short video from Chemical Safety Board on what happens when there's a lack of training.
On the morning of January 30th, 2007, an inexperienced technician prepared to transfer propane between 2 tanks at a convenience store in rural Gent, West Virginia. Suddenly, a geyser of propane erupted from one of the tanks. A large cloud of flammable vapor formed behind the store and seeped inside through vents in the roof. The invisible gas began to fill the store. The technician was unable to stop the release. All 4 employees remained inside the store, and the technician stayed by the tank as propane continued to leak for nearly half an hour. Meanwhile, 2 volunteer firefighters, 2 emergency medical technicians, and a second propane technician arrived in the danger zone. The area was never evacuated. At 10:53 a.m., the propane found an undetermined ignition source and exploded. The 2 technicians, the volunteer fire captain, and an EMT standing near the leaking tank were killed. The 4 store employees and the other firefighters survived, but they sustained serious burns and other injuries.
Nearly 30 minutes elapsed between the release and the explosion. If there'd been an evacuation during those 30 minutes, all of the lives would have been saved.
The CSB found the volunteer firefighters and the propane technicians were not adequately trained to handle propane emergencies.
If you see that vapor cloud and you hear it and you smell it, you need to be leaving it alone, and you need to evacuate the area.
CSB investigations illustrate the tragic consequences when workers and responders don't take appropriate defensive actions and risk their lives attempting to save structures or equipment.
We take the vow to protect life and property. Life comes first.
So what you have to do is you always review your high hazard areas. So look for, drums like that contain acid, or the other photographs shows you a drainage ditch that lead to the Caribbean Sea. And so what we have here is a boneyard of equipment that still contain hydraulic fluid, used oil, and so forth. So when it rains in the tropics, all that oil and hydraulic fluid get washed out of the equipment, go into this storm drain, and get washed out to the Caribbean Sea. So these are what I would consider to be high hazard areas that you need to pay attention to in order to avoid chemical accidents. So obviously the first focus is to get rid of all the equipment that are stored outdoor, exposed to the element. We can scratch this thing. Look at the way you store your anhydrous ammonia tank. How is it protected from traffic, from forklift trucks, and so on? And so these are things you have to pay attention to. So there are basically 4 principles that you need to adhere to when you develop an emergency response plan. The first principle is it has to be concise. By that I mean it has to be specific to the nature of what you're dealing with. Don't put in a lot of unnecessary verbiage, a lot of unnecessary pages in there just to make the document look hefty. And the second principle, it has to be realistic in the sense that what you describe, whatever emergency you think might happen, has to be realistic. And then the third one is ownership. Your employees who are going to be the third one is ownership. It is important for your employees to have ownership of the plan. By that, what I mean is that your employees ideally should have worked on the plan or be a part of the team that developed the plan, so that if they have been involved in it, they would have some sort of ownership. Because if there's no ownership, chances are your emergency response plan will never be implemented. And then the last principle is you have to deal with the worst case scenario in a realistic manner. So your worst case scenario cannot be underestimated, and that's what happened with some of the major chemical accidents. Some of the, for example, like the BP oil spill several years ago in the Gulf of Mexico. Their emergency response plan was over 500 pages long, and yet after the incident, after the wellhead blew up, that document was totally useless to them. They had to start from square one and come up with several approaches. Why? Because even though the document contained 500 pages, it was not concise, it was not specific, it was not realistic, and the worst case scenario was way underestimated. So remember, when it comes to writing an emergency response plan, size does not matter. And that's one of the problems if you hire outside consultants to prepare your plan for you. The consultants will always give you a hefty document because they want you to feel that you're getting your money's worth. So they're going to put in a lot of fluff, a lot of fillers in there that are totally unrelated or have they're not related to emergency, just to make the document look good. And that's what happened to the BP case, where they actually did a lot of cutting and pasting, and they inadvertently included walrus as one of the mammals that would be impacted by an oil spill in the Gulf of Mexico. Now, we all know that walruses do not live in the Gulf of Mexico, they live in the Arctic Circle. So what happened was that the consultants who was preparing this emergency response plan for BP in the Gulf of Mexico simply cut and paste, took some page of an existing emergency response plan in the Arctic Circle and put it and pasted it into the Gulf of Mexico document, and forgot to delete the reference on about walruses. So they got caught that way. So let's recap what you need to do. The first step is identify the chemicals you have on site. And second step is to read your list of lists, read the safety data sheets for proper storage procedures, use the list of lists to identify your reportable quantities. Once you know what chemicals you have on site, so that's the best way to prepare for a future accident, so that when the accident happens, you have at your fingertip exactly the trigger, the amount of spillage that would trigger a reportable event. Because not all your chemicals are 100%, not all your chemicals contain 100% pure chemicals that have the reportable quantity numbers associated with it. So you have to do some calculation based on the composition of your chemicals. Review your high hazard areas and do a workable emergency response plan based on the principle we talked about: concise, realistic, ownership, and worst case scenario. And step number 6, make sure you know your state's spill reporting requirements. And the last point, make sure you have community planning. Make sure you let your community know what kind of material you have on site. Make sure that you have a effective communication system to communicate any accident that you may have. And the last point is make sure that all your employees have the necessary training to deal with such an emergency. So if you have any questions about this video, feel free to contact me at proactenv.com. That's my email address. Or call me at 360-490-6828. Remember, you are entitled to 1 hour of free consultation with me on this particular subject, either by phone or by email. So, thank you very much.